Hey everyone, thanks for joining. John here, senior software engineer with 10 years of experience working on some Leetcode. This is blog article number 3, the Leetcode kata, which is a whiteboard interview preparatory regime. And in this video, I want to work on course schedule. So I have not touched this problem in a while, so this is what I'll call rusty mode. And let's work through it together. There are a total of num courses you have to take, labeled from 0 to num courses minus 1. You are given an array of prerequisites where the I of prerequisite is AB for I. It indicates that you must take course B if you want to take course A. I think this is an adjacency list, if I'm not mistaken. So you need to take B if you want to take A. Okay. For example, the pair 0, 1 indicates that you have to take course 0. Oh, that in order to take course 0, you have to take course 1. Cool. Return true if you can finish all courses, otherwise return false. So example 1 is going to return true because there is prerequisite 1, 0. There are 2 courses and there's prerequisite 1, 0. So I guess given that there are 2 courses, we imagine an array that is linked to some other array besides prerequisite, like an array of actual courses. Okay. And in the second case, 1, 0, 0, 1, so that creates a cycle, so it's not possible to complete. It's like it's like describing a chicken and egg problem, basically. Okay, so this is like chicken and egg detection. Can finish, so we'll return true if there is no chicken and egg problem, or probably the more straightforward mental models will return true if you can complete the courses. So how do we know that you can complete the courses? I'll propose that we need to know, let me write down some notes here. We need to know the list of courses and their dependencies. We can scan through the list many times, trimming courses for which prereqs are satisfied. If we hit the case where all courses are satisfied, then we can return true, else false. So this gives us a success mode, but the problem is there is also a potential infinite loop in this approach that I've just outlined. So how do we escape the infinite loop? Typically, when we think about cycles, so chicken and egg problem is cycle-like. So cycle-like problems can be solved typically by an escape cache or fast and slow pointers. So those are 2 modes that you can typically escape forms of looping. Fast and slow pointers, you're going to want to have something that you're traversing, and it needs to be a circular thing. We could construct such a thing, but it seems to be like a strange abstraction. So I think a cache is more intuitive here. Okay, so let's say that we build a cache. What's going to be in this cache? Potentially every course. So we will need an O of n cache. And so if I have an O of n cache, then how will I know that this thing is impossible? So let's look in the example of case 2 where we have a chicken and egg. So we want to detect our chicken and egg problem. And I've built out a list of all courses. So there's num courses 2. So I have this array 0, 1. And I have tried to trim. And I have not been able to trim any. So I don't need a cache of all the courses, I can actually just get away with a counter. So we can use a counter as a cache. And if nothing has been eliminated, that means there's a chicken and egg problem. If I go through a single pass and nothing has been eliminated. This is actually a really, really efficient approach because I only need n+1 iterations. Like on the iteration where the problem occurs, I'll immediately know. I don't need to like rescan a map or anything. I'll immediately know in a one operation lookup. Mike, thanks for the follow. Appreciate the likes on TikTok. Awesome. Already over 100 likes. By the way, you can go to YouTube or Twitch. Link is in my bio and see the full screen. Okay, so an escape cache seems more intuitive because we don't need to construct like a flat array or linked list. So they give us an array, but it's not in the shape that we're looking for. It's not a flat array. This adjacency list is like not a flat array that allows us to sequentially traverse. It's like hard to traverse. It's like not a graph. So we could create some graph, but in the escape cache pattern, we don't even need to do that. Fast and slow pointers seem less intuitive because we would need to build a graph. With the escape cache, we can get away with a simple counter of like would it be satisfied depths or unsatisfied depths? I guess you could do either one, satisfied or, well, I need to pick one. So you could do either one, but for the purpose of our implementation, which do we pick? We can go with num courses itself. Can we mutate num courses itself in place? So num courses itself, in the case of example 1, let's say that it's value of 2. And let's say that I decrement this value every time I found a soluble course or a satisfiable course. I don't know. Yeah, that jargon is fine, isn't it? Trading Pig, thank you for the follow. And George, thanks. Okay, so yeah, I think I can mutate num courses in place, and then you decrement it and you hit 0 and boom. So I don't need, so if we use the num courses that exists, this will be an unsatisfied counter. Do you see how, because it comes in as 2 as default, then it's an unsatisfied counter and we decrement it to 0. When you have 0 unsatisfied, you can finish. We can get away with a simple counter of satisfied or unsatisfied courses. The simplest thing to do is decrement num courses as an unsatisfied counter. In this case, space complexity seems like O of 1. It seems like O of 1. It's hard to beat that, isn't it? Topological sort, Ali. Please don't just roll up and shout out the answer. I hope that's wrong, because the approach I'm taking here is not a topological sort approach. All right. Is it Ali or Ali? Either way. So let's go forward with this approach. So I don't need num courses. It's already there. What else do I need? Like not much. I just need the list. So num courses can generate an array or a hash map or a set. Do I need any of these things? I think so. I think I need at least one of them. I'm going to go for a satisfied set. So yeah, instead of decrementing num courses, this will end up being potentially O of n, won't it? So it'd be nice to avoid this. So num courses refers to a virtual list of courses, but do I need to instantiate a literal list? I'm gonna go with no. I could be wrong here, but my intuit, like I at least want to try to not hold a O of n cache of any kind. And so I'll try to implement this, and if I fail, we'll come back. If I fail, we'll come back and build this. Try to not need this, but to do. Maybe I need it. Okay, so I'm going to try to not do that. So in that case, I'll simply say while, while num courses, and then I'll just have priv. So priv equals num. Maybe we'll call this priv unsatisfied. Let's do some underscores because it's Python. Priv unsatisfied count equals num courses. Well, I tried to give you snake case because it's Python, but then you gave me the camel case argument. Priv unsatisfied count is num courses, and we'll say while num courses to do decrement if allowed, and then we want to check versus priv unsatisfied. Okay, so then here, if it didn't change, there's a cycle or chicken egg issue. So then we'll return false because we can't finish. Okay, so decrement if allowed, and then now you do the comparison. And if we pass the comparison, now I want to store this new one. So now we store the new one, and then we'll iterate. Okay. Now if I make it all the way out here, that means num courses got down to 0. So the unsatisfied count got down to 0. So I'll return true. How many Leetcode since layoff? I've really only been practicing the kata, and I'm really only up to number 8 or 7. I think I've done maybe 3 problems outside of the kata. So I worked on Minesweeper. That was fun. So maybe 10 distinct problems, but then the problems that I have worked on within the kata, day 1, I do one, day 2, I do the next, and then I'll repeat day 1. So the earlier ones I've done like many times. So yeah, 2sum, maybe I've done 2sum 20 times, something like that, like between 10 and 20 times since I got laid off. Also, why did they lay off? Are they poor? Oh, I think I can't say anything about that. I think my severance agreement says that they're going to pay me money so that I don't talk about that. So no comment. And thank you for the severance. I am eligible for rehire there though. So I actually applied right back with them. Okay. There's a potential problem here. So what's the potential problem? The potential problem is, how do I know that your dependency was satisfied? So in the case of 0, it's very easy to go, oh, you have no dependencies, so let me trim you. So I do need O of n, because I need to say these courses have been satisfied, and in the worst case, n-1 courses, which is asymptotically n. Okay, so can I get away with this? So now I do need O of n. So can I get away with a set, or do I need a hash map? Because I need to store the key somehow. I think I can get away with a set. So get away with a simple counter. Amendment. Simple counter doesn't work. Because, okay, like what if I just have my okay, hold on. Maybe I have 2 pointers. Before I go for O of n, let me consider the case where I have 2 pointers. So I have my previous unsatisfied count, and I have my previous satisfied course index. So what if I just point back at the course that I just trimmed? The problem there is that in the worst case, that will be n-1 courses. Yeah. Because there won't just be one course. I might have satisfied multiple courses on a single iteration. Yeah, so I'm very convinced that I need O of n satisfied set now. Simple counter doesn't work because I can have multiple course recs per course, and I can satisfy multiple courses per iteration. O of n-1 in the worst tracked case. In the worst case, you satisfy them all in one pass, but in that case, you actually don't need a cache. So it's not the worst case; it's the worst tracked case. This is 207 course schedule. Good question. Thanks for being here in the chat. Go ahead and tap the video, give it some likes. Let's get some likes on the video to celebrate the identification of the satisfied set, huh? I think we basically have a proof on it at this point. Let's celebrate that. Market will come back in 2025. I think so. The market is already coming back. Let me show you something. A brief distraction. This will take less than 60 seconds. LinkedIn Market Insights. Is it this thing? You can put a job post title, and it will tell you like this. I guess this is the recruiter side. It'll tell you whether those job titles have been growing lately or not. LinkedIn Senior Software Engineer growth over time. I think it's called Talent Insights, but it wasn't shown. Ryan Peterman, what's up? This is like tailored to me or something? That's crazy. Or is he really like actually the top result for that? So Senior Software Engineer has grown 10% over the past month, and LinkedIn Talent Insights told me that, but like now I can't figure out how to get there. Is it my saved job titles? Is that how I found it? So let me go to jobs. Senior Software Engineer. All right, team, I'm sorry. I'm gonna have to like not show you the thing I wanted to show you. Somewhere around here, it'll tell you whether that title has been growing recently. Talent Insights. This is like a sales page. Can I just use it? I've definitely seen it. Whatever. All right, that was a total L. Sorry, guys. That was a total L. So let's get back to this. So I have this satisfied set. While num courses, if prev satisfied, so let's decrement if allowed. So I need to do an O of n pass here. So is this going to be O n squared? I didn't actually write out the time complexity. We can scan through the list many times, is what I said. Yeah, in the worst case, so this is like O of n squared. Okay. Because num courses, I'm going to look through this. And for each iteration, I might need to look through O of n courses. DFS with cycle detection, right? Y'all, don't drop the answer in the chat. Joe, welcome, welcome. My implementation here so far has not been DFS, but yeah, that might work. That might work. And it might be a better solution than what I'm doing. So if I ran this DFS, then I might be able to do this O of n. So I'm not going to do that now. I'm going to do what I was doing. But yeah, DFS might be a better solution. Okay, so let's continue with this. And then when I get to the end, I'll submit it. It'll either pass or fail or TLE or whatever. And we might look up the solution and find out DFS is better. Okay. So let's look through O of n courses. So for I in range, length, or like range num courses, is that going to work? It will work on the first pass, but if I'm decrementing num courses, it'll fail. But I'm not decrementing num courses. So instead of while num courses, I want to say while previous is less than num courses. So with that comparison, we can continue this way. If not I in satisfied. So if it has been satisfied, we don't need to check if it's now satisfied because like it already is. If it hasn't been satisfied, we want to now check on this iteration whether it's now satisfied. So how do I look this up? The way that I look this up is requirements are prerequisites So this is what I was thinking to do, but I don't think that you're allowed to do this. You're not allowed to do this. I would need to scan through prerequisites. Okay, so let's build up we're going to need a hash map as well. Let's build up a hash map of prerequisites. So here's rec map equals, we'll just put a dictionary now there. We'll come back and fix that, but this does alter our space complexity. It's going to be max of O of n, O of m, such that n is the number of courses and m is length of prerequisites. Is it n or m? No, I think it's n plus m. I think it's n plus m. Yeah, so it's not max O of n, m, it is O of n plus m. That's worse. I want to get into coding and minor in computer science. Cool, do it. Welcome, welcome. Hope you'll follow the page. Damien says OM plus N. Yes. Thanks, Damien. Cool. So this is even less efficient than I thought it was. But that's okay. I think what I'm doing here is like the brute force approach, basically. So that feels kind of bad, but at least we have a path to getting an answer. Okay, so the requirements is, we need to build this requirements map. So the requirements map, and we'll look up I. Okay, let me go build that map. And I'll put a to-do here. Finish this block. Okay. So the requirements map is going to be, you can do like a nice comprehension here. Let's see if I can remember how to write a comprehension. Probably not. For foo in bar, key, this will be a key value for foo in bar. Is it something like this? So I have prerequisites. For cur class. Oh, course. Let's say course, not class, because class is overloaded with like technical classes. So for the current course, the key will be so in the pair 0, 1, you have to take course 1 for 0. You have to take course 1 for 0. Oh, you know what? Maybe you don't have multiple prerequisites. Maybe I'm overcomplicating this thing. Because I was supporting the possibility that course 0 might depend on 1, 2, and 3. But now that I'm rereading this problem, it doesn't appear to do so. Which makes me want to go back to the trim-based approach. Want to go back to the trim-based approach because as my numbers increase, if I ever got to a particular iteration, all prior courses are satisfied. And so, yeah, maybe I can use a counter-based approach. Easy dynamic programming question. Yeah, maybe. I don't know. I feel like an easy dynamic programming question is like it's like a contradiction. Let's see. Also, I'm pretty sure you can solve this without DP. I don't see why. Maybe you just mean you can use DP, I guess. You can use DP in a lot of places where it isn't needed, but I don't think you need to do DP here. Okay, let me proceed with my map-based approach, and then we might come back and say that I don't need a map after all. Actually, if you can only have one, actually, if you can only have max 1 depth per course, you might be okay with an iterator and no rec map. With a cached, like an iterator cached counter, or like just a counter, not a cached counter. Sorry, spoilers. Yeah, no problem. I already had someone else spoil it too, so that's fine. My approach here is not DF. How do you remember the commands? What do you mean commands? I was just typing on my keyboard. I didn't use a command. Okay, so key value here is going to be dependent course, and this is going to be prereq course. Prereq. Do I even need to say that? I think I could just say KV. Let me comment all of this and see if this syntax alone is correct. Did you forget the parentheses around the comprehension? I think I did. And I don't know where they go. Bummer. Where does it go? KV. K is not defined. Okay, let me just do this the boring and reliable way. For course in prerequisites. Rec map. The key will be depth course. Prereq course and prerequisites.items. I don't know that I need the dot items, do I? Maybe I do. Okay. List has no attribute items. Okay. So 1 depends on 0. Did I do this properly? 1 depends on 0. Yeah, that's right. Okay. So now I have my I. So here I'm on 0. So we start at 0. And if not, I unsatisfied. So 0 is not yet satisfied on the first iteration. Is it good to go now, though? Well, we need to find out the requirements for 0. And let me use a dot get. And now I can say if rex. Chris Rechtenwald says topological sort. No, I don't think so. I don't think so. What's your approach right now? I usually do Leetcode in Java, so I'm not sure if there's Python magic. No, there's not much magic here. This is like a pretty basic while loop. The approach is just an iteration-based pattern. I think it's kind of a brute force, basically. Okay, so if requirements to do finish this block, else you're automatically satisfied. Satisfied dot add I. And priv unsatisfied count is, I don't want the priv unsatisfied count. I can just use my satisfied dot size now. And I can use not equals. So while the satisfied dot size is not equal to the number of courses, and if that ever breaks, then we can return true. Okay. And while the condition holds, we are going to like say, hey, let me look through all of the courses 0 to n and check, like, let's just go through all of them, and whichever ones previously were not satisfied, are they good to go now? Okay. So let's consider a test case with like 3 courses that are interdependent on each other, like 1, 2, 3, or 0, 1, 2. Okay, it's like a domino, 0, 1, 2 in this test case. So 0 is going to be added to satisfied, 1 and 2 won't. Like, cool. And I could short circuit this. That would not improve worst case complexity, but it would improve average case. Is that as soon as I add a single one, I could break. Okay. So if you do have requirements, are they in the map? If requirements and recs in satisfied. Cool. So I can basically join these. Or not recs in both of these conditions. In both of these conditions. Cool. All right, so we get through all of the courses and we've updated it for this iteration. Now this thing is wrong here. It didn't change. There's a cycle or chicken egg issue. Priv unsatisfied count. So here let's use priv satisfied count. Priv satisfied count, and the comparison is now with satisfied.size. And if they're different, we will update. If they're different, we will update. And we'll initialize that guy to 0. Okay. Can num courses be 0? No, num courses is at least 1. If num courses is 1, we cannot immediately return true. I don't know, can we? Feels like if num courses is 1, I think we can immediately return true. Because how would it depend on anything? Does it depend on itself? I mean, I guess technically they could pass a self loop. Seems ridiculous. I think the smarter thing to do is if length prerequisites is 0. Then look, we can return true in that case. All right, so where are we at? What's going on here? Set does not have an object called size. Oh, really? What is it? Is it count? Or I can do the length of the set, I guess. Does a JavaScript set have size? Where did I get that from? Okay. So in this case, we're good to go. In this case, we're not. What happened here? Output was true, expected was false. Ooh, why was the output true? Your mom's got size. Nice one, Bailey. Solid. Solid. Let's add some logs. Let's add some logs. Something could be wrong here, basically. Because here, stuff is getting added to satisfied unexpectedly, it seems. So we can see how this I in range num courses, so 0 is not unsatisfied. Now I get the requirements for 0. At this point, I need to see 1 here. So let's print that. Maybe I'm calculating the requirements wrong. 101. Ooh, very programming style log message. This is definitely a program. What are programs, man? Here's one. So we print the requirements and it says 101. Oh, okay. The if requirements, it's a 0. And so it's saying that this condition is passing on 0. That's the issue. Falsy, got bit by falsy, is none, is the safer thing to do. Okay. Well, now the second case passed and the first case didn't pass. Interesting. How do I get a job in at entry level? Check out latterly.io. There's a checklist. There you go. Right there. Walks you through step by step the recommended approach to learn to code and land your first programming role. Okay, so how about here? None. None in satisfied. I wonder if that's always going to be true anyway. Like, will you just say none is in satisfied? So here in the case of none, we should see 0 added. We should see 0 added. So I want to make sure that I got into here. And let me make this an F string. Okay, so we see 0 added. So satisfied adds 0. Then we come back around and we are checking on 1. We are checking on 1. So we just print I. So we do get to the case where I is 1. In the case where I is 1, we then print requirement 0. One is never marked satisfied. This makes me think that line 42 has some sort of bad logic in it. So we are getting to the case the answer is 1. Thanks, the bean. Thank you. The answer is 1, y'all. So we're getting to the case where we're on course 1. So we're on course 1. Oh. I thought, okay, I'm being very dumb here. I was considering example 2, and I'm waiting to get to index 1, which is the second item. There is no second item. So for I in range num courses, I should do -1 here. So satisfied I is 0. Serg says, what's up? What's this? This is Leetcode. This is programming interview preparation. Okay. So now satisfied length should be 1 at this point. Thanks for the rose. Thank you so much. Num courses is 2. Oh, that's why I'm tripping. I'm getting confused about this. So range num courses -1. There's 2 courses. We're still going to go 0, 1, aren't we? When the length satisfied is not equal to the number of courses. So range 1 will only pass 0. Is that what I'm understanding? I was thinking range 1 would go 0, 1. Okay, so range, as we were. So range 2 will yield 0, 1. Cool, I'm gonna check this out, my guy. Nice. All right, so I think we're back to the previous problem then. In this case, why are we not saying that the requirements for 1 are satisfied? So we say that the requirements are 0. Good, that's expected. And then we exit. So if, okay, because if requirements, it's the 0 again, is not none. Yeah, okay. It was just the falsy nature of the 0. Wrong answer. All right. What's wrong here? How often do you go live? I really enjoy the live coding practices. Thanks, Joji. Monday through Friday, once a day. Oh, this is a really good call out. So you go to latterly.io, community here. You can see the events calendar. And you can add this Google Calendar. It's an open calendar. And you'll see streams and other events like hackathons or whatever. But currently I'm streaming Monday through Friday at 3 p.m. Eastern. Then Tuesday, Thursday, Saturday, there's an evening stream, which is 8 to 9 Eastern. 8 to 9 Eastern. Okay, so good. At this point, I think this was a really good exercise, and let's look up the solution. So why is this wrong? So we have 3 courses, 0, 1, and 2. Okay. 0 depends on 1. 0 depends on 1. Requirements 1. So for 2, 0, 1, 2. Okay, so for 2, requirements none. That's the problem. Okay, my map is messed up. Wait. Oh, you can depend on multiple courses. So I guess I'm supposed to merge these 2. I would have expected this to be 1 comma and then a subarray 0 comma 2. So this matter of expression is different than I was expecting. So 1 does depend on multiple courses by means of 2 prerequisite rows. I think that will be a simple adjustment. So here, rec map and here I say rec map equals prerequisite course. Now I should say rec map.add So we'll turn that into a set. And now I should be able to express that 1 depends on 0 and 2. And here we'll use a default dict. Is there an underscore? I don't remember. So the sort of safe way is to do an if. And if it's there, we'll add it. And if it's not, we'll create the new set. And I think you can even pass a value right into the set, but I'll separately append it. And now I can see that I'm duplicating the expression, which means that I can extract that, and I'll just say that if it's not there, we'll make it. And then we will append it regardless. Okay. So if it's not there, we'll make it. If it's not there, we'll make it. And then whether we made it or not, we will then append to it. Okay. And now, instead of saying if rex is not none and rex in satisfied. Good. So we're still getting none or set. The difference is now that rex is a set. So I cannot say rex in satisfied. I need to say like all requirements are satisfied. So let me alter this. If rex is not none. The better thing to do, if rex is none, we'll immediately add it over here. And then else, if all members are unsatisfied. Okay, so if all members are unsatisfied, then we'll do this thing. And we're going to assume that's true, and then we're going to check them for rec and rex. Does that alteration make sense? So we assume that they're all satisfied, but if we find one that's not, then we alter the flag. Thanks for the likes, Brian. Cool. So we're still accepted on those test cases. And we got a TLE. Great. It looks like this is actually like a good news to me. And we have 46 out of 52 passed. It looks like this is a successful brute force to me. This doesn't look like Rust mode to me. Well, what does Rust mode mean to you? Because we're not using the Rust programming language. So Rust mode to me means that I'm rusty. And oh, are you just saying that like I'm doing too good? That's really nice. We have a successful implementation, but it's a brute force, so it's not optimal. And also, I think it took me like And it took me like an hour to do a brute force medium, which I guess the cup is half full. Is that like, I don't, where's my solutions, my submissions? Okay, so apparently I've never submitted an answer to this before. So the cup half full is like, okay, we got a solution in an hour. Yeah, I don't know. Like, what level are you interviewing at? So this would pass you at some levels, and this would not pass you at other levels. I'm trying to go for Fang Senior. So I don't know that this would work. I don't know that they would let me have it. Maybe if I knock out the behavioral, right? Which I do. I mean, I'm so personable. And on interview days, I even shave. So that's how you really pass a behavioral. I don't think this would work for junior either. Oh, roasted. All right. All right. So let's look at some solutions. We'll do 5 minutes on solution review. In the kata, this is marked as like a DFS problem. Optionally topological sort. Are they equally efficient? I don't know. So let's see which one is more efficient, or if they're equally efficient. 99 time 100% space. Ooh, this is going to be ugly, isn't it? What? Oh, that's building an adjacency list. I thought that was the whole solution. I'm a Rustlang guy. Welcome, welcome. Thanks for being here. We love Rust. Complexity analysis is V plus E. I think I said N plus M, right? So whatever, it tracks. So they're talking about vertexes and edges. So they do build out the graph. They do build out the graph. I avoided building out the graph. So here, cycle-like problems can be solved typically by an escape cache or fast and slow pointers. Fast and slow pointers seems less intuitive because we'll need to build a graph. So I was thinking that building a graph is like an extraneous step. And I'm still not necessarily sold. If the time complexity is isomorphic to NM, and they just translate it to a graph, so they call it VE. But if it's equivalent, like, what are we gaining here? Did y'all hear my upstairs neighbor? Nice. They even make a method called hasCycle. Wow, this is like surprisingly readable. Usually if you get like a 99%, like someone is like perf maxing, then the code is like garbage. But this is like really readable. Kudos to this person. Shuang Hung. Kudos, kudos. 42 out of 42 cases passed. There's more cases now. So they build an adjacency list. I thought prerequisites is an adjacency list. Do they do the tortoise method for cycles? Let's see. hasCycle process, so we pass. It does not look like it. No, it looks like they're using this state. So they're using a cache to detect the cycle, it seems. So maybe we can beat their memory, huh? Your usage beats 65%. So they're using like a scene cache. I like Floyd's algorithm more. Isn't that just fast and slow pointers? Isn't that just like the fancy way to say fast and slow pointers? Shortest path in a directed weighted graph. Oh no, this is something different, huh? I'm not familiar with this. Yeah, I think this is just another, like tortoise and hare, I think it's just another name for fast and slow pointers, right? Can you confirm or deny? I can never remember people's names, so that's why I want to remember what is the algorithm, like not some random name. So I really like calling, yeah, same as fast and slow or tortoise and hare. Cool. So as cool as that is, maybe we can improve it. But it's the implementation is a little complex as well, huh? I think we can do better. Let's look at their other answers. DFS with stack sort. This is already more concise, is it not? Oh no, maybe not. Build adjacency list is used regardless. So in every case, they're going to build an adjacency list. Whoa. This one's crazy. This one's crazy. Alien dictionary. BFS with Kahn's algorithm. Why are we using Kahn's algorithm? So here's a BFS. I'm going to keep a link to this. This is like a really nice solution. Okay, so the memoization approach is like a little inefficient because you don't need the cache, right? Yeah, okay. So why is solution 2 is DFS? Solution 2 is less efficient. That's surprising to me that DFS is using even more memory. So what are they using the memory for here? We build out an adjacency list. Okay, that's already more memory than I was hoping to. It's like more memory and implementation complexity than I was going for. Visited, fine, I get that one. And then you do for V in range if it has a cycle. So in the worst case, cycle checking will have O(n) squared, right? Is this not also O(n) squared? Maybe the worst case is the same, but it's like it amortizes better because you end up escaping a bunch of cases later on. It's just O of n, I believe. CS is over by 2028. Nice. I'd love to place bets on that. Love to place bets on that. Oh, what is stack? What are we doing with this stack? What does the stack give us? if it's visited and it's in the stack, it's being processed and it means we have a cycle. Okay. That's how we short circuit it, basically. No, this is still an O(n) squared solution. So the cycle detection itself is O(n), but you're V(n) ranging. So your V(n) ranging, which is O(n) over an O of n, I think it's still O(n) squared asymptotically. Wall Street bets, does it work? No way, right? Like you can't just like bet on Reddit. Reddit doesn't work for me. Every time I post there, I get canceled. Okay, so it's asymptotically O(n) squared, but you're going to be escaping really fast. So that's cool. So it amortizes really well. And it's worse memory because you also need this stack. That's the reason it's taking more memory. So you have the adjacency list, you have the visited set, and an added stack. Okay, that one makes sense to me. Kane's algorithm. I'm not sure what that is, or Kahn's algorithm. You know the guy who posted himself losing minus 50K in seconds? No, I'm not familiar. That's crazy. Would you recommend someone to go into a computer science major? Yeah, I mean, if they've been accepted to a good school and the tuition isn't crazy. So my advice, like I have a PhD in economics, so I like to actually look at your return on investment. So I want to know like what school are you going to? What are their outcomes? What is the cost? Are you getting any scholarships? So I want to personalize my advice that way. But in general, CS is a good degree. So if you're not paying an outrageous price, and if you're going to a good school, it's a good investment in general. Okay, so I'm understanding why we get to solution 2. Although solution 1 seems to be even better, doesn't it? So solution 2 is fatter and slower. What's the max you would pay for a CS degree? Oh, okay, that one's tough to say. Let's see. Undergrad. I don't know. I haven't been in school for a while. I think the typical state school is. I would pay whatever the typical in-state tuition is. Average in-state tuition. University. And mandatory fees for in-state undergraduates. Dang, that's so much, isn't it? So this is 25 grand a year. Is it really 25 grand a year? The average cost for out of state. I would try to beat this. I think you can beat that. I mean, 25K a year, like if it is a good school, I'll pay it. But I feel like you can beat that. So look into options like, okay, room and board is 10 grand, but do you need room and board for all 4 years? Probably they're going to let you work. Probably they're going to require a year or 2. Some colleges won't have any board requirement. So if you have multiple in-state options, prefer that which doesn't have an in-board requirement. So I would go up to 100 grand if I really had to. I would go up there, but I would try to get closer to, yeah. I'd try to get under 50, to be honest with you. Try to get under 50. Or go to a community college and transfer to uni after 2 years. Yeah, that's a great advice. That's actually what I did. So University of Houston, I went to Austin Community College for 2 years, then went to University of Houston. Average community college. Yeah, that's way better. That's way better. And you can even do out-of-state community college cheaper than in-state four-year, right? So that'll save you, shoot, that's going to save you 40 grand right there, won't it? Are you kidding me? So about 5 grand versus about 25 grand. There you go. There's other things you can do to like get credit by exam, credit by portfolio, AP credit, all this stuff, and accelerate your degree. Basically, that's all really good advice, and I do support it. Practically, though, like most people don't do it, but people should be considering that. You can make a GitHub portfolio and have an ACE credit review on your portfolio and get college credit for that. That's a win-win-win because you should be building the portfolio ASAP anyway. It's demonstrated experience to employers. So you can collect experience on your resume throughout college. You can graduate college with 4 years of experience. You can do it. You can do it if you're one of these people who starts the portfolio like senior year of high school or whatever. If you're in high school, you can do a dual enrollment if your GPA is good. Exactly. Yeah, just like AP exam and other stuff, dual enrollment's another option. These are great advice. These are great advice. What I wouldn't do is I wouldn't go out of state, and I wouldn't go to a Harvard unless they gave me a scholarship, right? Or, I mean, if my parents are rich or something, I guess there's that. But for the typical person, that won't work. Imagine 8% on 100K debt. Yeah, no way. That's terrible, right? I'm with you. But we talked about how you can drop 40 off that right away, right? And so I think I told you I'd try to go under 50. Isn't that what I said? Yeah, 8% on 100K is unreasonable for sure. Well, this was a great stream. Oh, let me actually I'm trying to understand the best one. So we understand solution 2, but it's like not the best one. Poppy Sensei, what's up? So solution 1 is going to be faster and less memory. Do we understand solution 1? So what are we doing here? Build an adjacency list. And then we just check cycles. So you build an adjacency list and you check cycles. Why is that faster? It seems isomorphic to what I did. Why is that faster? So V plus E, V is the vertices. The vertices will be the courses. So you're traversing a course graph. The vertices will be the courses. So in the V plus E math compared to N plus M, which is what I have, V is N. There's no difference there. So what about this edges thing? So in my math, NM, M is the row count in prerequisite. The row count in prerequisite, and each of those defines an edge. So M is E. So definitively, V plus E is equivalent to N plus M. So there's not a difference in the space complexity. Okay, there's not a difference in the space complexity. Is there a difference in the time complexity? Here, I'm seeing a V in range. That's an O of N operation. And for each N, we're checking if it has a cycle. And to check if it has a cycle, okay, the cache is getting it. It's, yeah. In the worst case, I think it's still O N squared. Because in the worst case, you have to dive all the way down the stack, right? In the worst case. In the worst case. But you will only need to dive down the stack once because you build out this cache. You will only need to dive down the stack once. That's the reason it's better. So yeah, it's better on the order of n, attributable to this memoization. That's the reason it's better. Fantastic. I love an L. I love an L if it teaches me. Thanks for your advice, man. I'm cooked regardless. Continue your teaching. Oh, hey, no way. If like that was not my tailored advice for you, homie. We can do a lot better. Are you still on the stream? Yo, that was just like very generic, basic advice. So you can book a call with me and I can give you a lot more detailed advice personalized to you, including more exotic options. So if I don't know what your position is, were you a senior in high school or something? You asked if you should enroll in college. Here's an exotic option that has a much better risk-adjusted return on investment. Consider the option of a boot camp over a gap year. A boot camp over a gap year. If that succeeds, and it's not guaranteed to succeed, but it doesn't have to because you're not trading college for a boot camp. You're only trading a gap year for a boot camp, which is going to improve your life satisfaction anyway. And by the time you come back, if you think of what the economy is expected to look like next year, those interest rates are expected to look better next year. So a boot camp within a gap year right now is looking great. Again, contingent on your particulars, I would want to have a call with you and make sure that you can qualify for a decent boot camp. But if you do succeed on that, if you are one of those people accepted to a boot camp and then placed, you'll be getting a job 3 years faster. So you gain 3 years of opportunity cost, and the $50K cost for college, the 3 years of opportunity cost is three quarters of that. So that's like, I don't know, 40 grand right there. So you'll get 40 grand just on the savings. Forget about your earnings. And then the earnings is, let's say that you get that programming role, you get it, maybe you're getting 60K super conservatively. That's hundreds of thousands of dollars because 60K times 3 plus the 40. So that's 180 plus 40 is 220. So that's hundreds of thousands of dollars in opportunity cost. Now, it's not a safe bet, so you need to do a risk adjustment, right? But it's pretty safe because even if the boot camp fails for you, you can still carry on to college. It's just a gap year. It's unremarkable these days. So there are many, many much more optimal strategies if you want to book a call with me, which I highly recommend, other than the super generic advice I gave a moment ago, which is like, try to pay less than 50 grand for your 4-year. Again, the 50 grand would be a good investment. It's just that you can do better. You see what I'm saying? I'm not saying that 50 grand is a bad investment. It's certainly better than doing nothing. Okay, that was another fun tangent. So we understand why solution 1 is awesome. It's awesome because memoization. So every time in the future where I see course, this is course thingy. Can you finish your course problem? The answer is use memoization. Use memoization. So we're going to have, well, at least in this solution. In the worst case, we dive down the stack and use memoization. And it's absolutely worth it to build the graph because even though that's painful, and yes, it costs O of n, but, and indeed, we have multiple structures calling for O of n. So we have the adjacency list O of n, we have a state O of n, we have this O of n range check, but having even several O of n operations is much better than having n squared, right? So I'm totally sold on this. Now, what about the crazy one? Let's see if I can get my small brain around this crazy one. And it's BFS. It's just like so counterintuitive to me. BFS is dominating the world, really? It's a topo BFS. It's a really good thing I included this problem in the kata because this is a really interesting it's a really interesting pattern, a topo BFS. Okay. So we build an adjacency list. We've already made the argument about why that's going to be useful regardless. So we accept that we have an adjacency list. Cool. Now what are we doing? In degrees, a list stores the number of incoming edges for each vertex. That seems super weird. Okay. I'm not sure what, like, I understand what you're saying. I don't know why we're doing it. I understand what you're saying. I don't know why we do it. So we have a list that stores the number of incoming edges. And then we have a queue. Oh, because it's a BFS. Because it's a BFS. Okay. So we need the incoming edges so that I can do this queue. So I have this list. Incoming edges starts out as a list of zeros. What's edges list? Edges list is coming in the problem as prerequisites. Prerequisites. Oh yeah, they just rename it to edges list. That's smart, right? Because it is a list of edges. We proved that earlier. Okay. So we start with a list of zeros. We're going to append them. And then now I have for vertex and range num nodes. For vertex and range num nodes. So like for each course, if that course has no, if that course has no edges, then it has no dependencies. We're going to eagerly append it to a queue. Cool. So we're starting with these guys. We're starting with the guys that have no prereqs. Yes. Clear as day. We're starting with the guys that have no prereqs. And what do we want to do now? We want to initialize a count of visited vertices. Yeah, okay, so it has the same short circuit idea that I implemented. That makes me feel great. Hey, I might have done an n squared variant of what you're doing, but we shared some ideas, didn't we? Because you have a counter too. Hell yeah, dude. You have a counter, I have a counter. We some counters out here. Do you know MATLAB? I just told you we're some counters out here. Of course we know MATLAB. We're all about the maths. We're all about the maths. Cool. So I'm going to BFS. We're going to start with like the ones where the things are satisfied, and then we're just going to keep cycling them. While Q, we pop the Q, we get my current one. Topo order. What is this thing? It's just another list. It will contain the final topological order. So we're creating topo order. We increase the count. For each descendant of the current vertex, reduce its size. That is the interesting piece. That's like a very different thing than what I did. So for each descendant of the current vertex, yeah, so I was checking if you're satisfied by looking in a set. They're checking if you're satisfied by decrementing a dependency count. That's fine, right? It's O of n either way. It's O of n either way. Can you do decode string next? Not today, bud. Feel free to join laterally. You can sign up to Discord and drop a note on the channel. We're done coding for today, and I'm just trying to get my head around the solution, which is, I'm very pleased to say it's genuinely going well, but we're not going to be doing another problem. Thanks for the follow. Okay, so this solution is extremely readable. Again, kudos to this person. Like, this person rocks. Xuan Heng. We got three different solutions, and it's really clear here why BFS is acceptable. So with BFS, we're going to need this queue. Often it's not preferred because you have to allocate that memory, but we know you already need to allocate O of n because of an adjacency list. So there's no loss to the space complexity, right? It's not, and so, but you get so many benefits of this approach. Thanks. I'll join the Discord. Awesome. Thank you so much. Thank you so much. And over 1,100 likes on TikTok. Thanks again, y'all. For next time around, you can go to the link in the bio and join YouTube. Nothing wrong with TikTok, like no shade, although it might get banned soon, so that would be bad. But the real reason to go over to YouTube is so you can see the full screen and the saved streams. The full screen and the saved streams. Okay, so we just calculate the Q. So we set up BFS and we calculate the Q. Why does this topo order matter? It matters because we're going to return it at some point. Why are we returning it? Return true if topo order. Oh, that's weird. What about the edge case where, yeah, if there's no courses, I guess you cannot finish. That seems counterintuitive, but I guess it's fine. Yeah, well, it's fair enough. In one sense, if there's no courses, you're already done. But yeah, in another sense, if there's no courses, how could you finish? There's nothing there. So I guess it works. The intuition works both ways. And then if you have even one course, Cameron, thank you for the follow. So if you have even one course, you're going to queue up, you're going to append. Yeah, so you'll have some courses. I'm just a little confused why here we return topo order. We don't just return true. Why don't we just return true in that case? So what if I ran, because if I ran through my queue, if I ran through my queue and I didn't grow this topologically ordered list, if I didn't grow it, yeah, then count would not equal num nodes, right? It seems like there's like a duplicate use here. Like I could, I could just not use count and I could just use length of topo order, right? Let's test it out. Oh, this is gonna be great. I'm gonna feel so happy if the last thing I do is improve on this guy's solution and it's already like a goated, impossibly cool solution, and then I beat it. So we're gonna copy this thing. I'll paste it over here. And let me go get the implementation of build adjacency list. Okay. Cool. All right. So we're going to just sanity check that this thing runs. Unexpected indent on the solution class. Okay. Gotta love Python. Okay. So that works. Now, John's crazy theory is, hey, I can maybe not use count at all. Oh, wow, you're everywhere. Alfredo, what up, what up? I can maybe not use count at all. And just use the length here. Yes, I saved you a pointer, homie. I saved you a pointer. There you go. I have improved on the world's best solution. I guess now it's only in the 90, it only beats 95% or whatever. Let's submit it again. I'm going to harvest some random variation to my benefit. Ooh, yikes. Same solution. We're down to beats 81. And if I introduce the counter, does that help somehow? Oh, because the length operation is slow. Is that the reason we did this? Now we only beat 55. Okay, this guy said he beats like 99, but the variation is wild. It like doesn't make a difference. Like 90 is equivalent to 30 in this implementation. Whatever, I saved you a pointer. I'm a rock star. Google, get your checks ready. I'm a rock star, and so are you guys. Thanks for being here. Thanks for following the page. I love your faces.